Hello everyone, welcome back to our YouTube channel Esculenta Science. If you are new to here and want to learn about the food science and technology, please hit the subscribe followed by the bell. Today we are going to learn about oxidation and oxidative stability in emulsions by reading a manuscript. Here you can see the topic of the manuscript. It is oxidation and oxidative stability in emulsions. First, let's have a look onto the abstract. It says that emulsions are implemented in the fabrication of a wide array of foods and therefore are great importance in food science. However, the application of emulsions in food production is restricted by main two factors, that is, physical and oxidative stability. There are different measures to render oxidative stability. These strategies are scrutinized in four main categories, namely storage conditions, emulsifiers, optimization of production methods, and antioxidants. Emulsions are complex systems comprising of two or more liquids, with one being dispersed in the other one. Emulsions are divided in terms of size of droplets such as regular emulsions, microemulsions, and nanoemulsions. They can also be categorized according to their method of stabilization, that is regular emulsion and Pickering emulsions, where solid particles and adsorb in the interface between two phases of the emulsion. Emulsions are applied in various areas including food science, cosmetics, medicine, and construction. Here in this figure 1, you can see different types of emulsions. They are oil in water emulsion, water in oil emulsion, water in water emulsion, oil in oil emulsion, oil in water in oil emulsion, water in oil in water emulsion, nanoemulsions, and Pickering emulsions. Oil in water emulsions contain two immiscible liquids, with oil being dispersed as spherical droplets in water phase. Milk, mayonnaise, cream, dressing, cream cheese, and soups are examples for oil in water emulsion. Oil in water emulsions can be classified into two categories according to the dispersed phase, volume fraction, low fat and high fat. Water in oil emulsions consist of an aqueous phase dispersed as spherical droplets in a continuous lipid phase. Products such as butter, spreads, margarine, and cocoa butter are examples for water in oil emulsions. Oil in oil emulsions, also known as water-free emulsions, anhydrous emulsions, and non-aqueous emulsions, are in fact mixtures of immiscible oil, for example, vegetable oil and silicon oil stabilized by particles. Multiple emulsions, also referred to as double emulsions, consist of a complex system of an emulsion within another emulsion. Multiple emulsions are mainly of two types: oil in water in oil and water in oil in water. Oil in water in oil is oil dispersed in water, and then this emulsion is dispersed in a second oil phase. Whereas in water in oil in water emulsions, water is first dispersed in oil, and then this emulsion is dispersed in a second water phase. Nanoemulsions are thermodynamically unstable systems with small droplet sizes ranging from 20 to 200 nanometers. Pickering emulsions are formed by use of solid particles that adsorb at the interface between two phases of the emulsion. In other words, they are the emulsions stabilized by solid particles by which thick interfacial layers are created around droplets. As mentioned in the abstract, lipid oxidation is a main problem with emulsions. Lipid oxidation increases with the increasing temperature. At moderate temperatures, heat primarily promotes oxidation by breaking the oxygen bonds in traces of lipid hydroperoxides. This gives rise to formation of alkoxyl and hydroxyl radicals, which can initiate oxidation. For that reason, emulsions rich in unsaturated lipids should be stored at as low temperature as possible. The other method to prevent the lipid oxidation in emulsion is emulsifiers. Emulsifiers are surface-active substances which are able to rapidly adsorb at the oil-water interface of emulsions, decreasing interfacial tension and preventing droplet aggregation. Emulsifiers have a crucial role in forming and stabilizing emulsions, thereby providing physiochemical stability. Emulsifiers are commonly used in commercial emulsion-based food products such as milk, yogurt, mayonnaise, salad dressing, and coffee cream. Even though using only one type of emulsifier can be sufficient to emulsify oils, combined use of different types of emulsifiers are quite common in food emulsions as a strategy to provide better physical stability as well as to protect lipid against oxidation. The efficiency of using more than one type of emulsifier in an emulsion depends either on the formation of emulsifier complexes that leads to enhanced interfacial layer or the competitive adsorption of each emulsifier at the interface that originates interfacial displacement. Optimization of production methods also can be practiced to avoid the oxidation of emulsions. Lipid oxidation can occur during the emulsion production process, but the emulsification technology and conditions can affect lipid oxidation after the emulsion has been produced. Therefore, the type of emulsification technology has to be chosen carefully and the emulsification conditions must be optimized. A range of different emulsification technologies are available, for example, high-pressure homogenization, microfluidization, mixing, and membrane homogenization. The other method of preventing lipid oxidation in emulsion is using antioxidant. Antioxidants are defined as compounds that delay the onset and prevent or decrease the rate of lipid oxidation. Compounds with antioxidant properties are divided into three different categories depending upon the mechanism of the compound, such as antioxidant. The three categories are termed primary, secondary, or multiple function antioxidants. Primary antioxidants are antioxidants that scavenge radicals. These antioxidants react directly with lipids, peroxyl and alkoxyl radicals to terminate the initiation and propagation steps of the lipid oxidation. Tocopherols, ascorbic acid, BHT, and phenolic compounds are common compounds with radical scavenging properties. When producing foodstuffs based on emulsions, one might wish to render oxidative stability to the system by incorporating commercially available antioxidants. However, studies have indicated that different measures are there to be taken so as to stabilize an emulsion to prevent the oxidative degradation of the system. These measures, which vary from the selection of emulsifiers to optimization the manufacture and storage conditions, might turn out to be even more efficient and economical. Oxidation and oxidative stabilization of emulsions is an extremely extensive field of study where every new study carried out brings along new questions and pathways for future research. You can read this review paper to get detailed knowledge about emulsions and emulsifiers and the oxidation and oxidation stability of emulsions. If you need any clarification, please leave a comment. And thanks for watching.